So I made this clock for Hackspace magazine a couple of months ago, and Adam got in touch and asked me to talk about it today. And I thought a bit about the clock, and there's like a few parts to it. And, there's the wooden frame, but to be honest, if you've got access to a saw and a screwdriver, you don't need me to tell you how to do it. You cut it up and you screw it together. There's the clock face, which if you've got access to a laser cutter, it's really easy to do. If you don't, there's actually one at Bristol Hackspace that you can join and use, and it's just like printing a document, but it cuts out of plywood. Again, it's not really worth a talk on. It's all controlled by an Arduino microcontroller. Basically, it's just a really simple embedded computer that can talk to Wi-Fi once every minute or so, grabs the latest time from the internet, converts it into an array of colors, and spits that out. Again, you're programmers here, you don't need me to tell you how to do a little bit of jiggery-pokery on that. The interesting part of the technology, for me at least, is the way it lights up the letters. So there's 104 letters. Behind each one of them is 3 LEDs, a red, green, and blue. And those can be combined to create any colors. At the moment, they're just fairly boring colors, to be honest, because I quite like boring colors. It could be pulsing rainbow if you wanted it to. And so there's 312 LEDs back there. That alone would be quite a lot of soldering together. And LEDs, they're either on or off. If you want to combine colors in different ways, you have to flick them on and off really quickly, a few hundred times a second, the same way a screen works, really. So you've got 312 LEDs that need to be flicked on and off a few hundred times a second, which is kind of possible to manage on a microcontroller, but it's difficult, especially when you've got to manage the timing with Wi-Fi and everything else. But fortunately, there's a much easier way that you don't need to worry about any of that. And it's these things. They're called WS28125s is their technical name, but they're commonly known as NeoPixels, which is really kind of a trade name, but we'll get onto that in a bit. And these are really simple. So each dot is an individual device, and this is just on a sort of flexible PCB that they come in. And each NeoPixel has got 4 connections. It's got voltage in, ground, it's got data in and data out. And all you have to do is connect the data out of one to the data in of the next, and you can make arbitrarily long chains of them really easily. And you can combine different types in all sorts of ways. They're kind of like R limits to how long you can get, but it's mostly to do with how much memory you've got in your device, how much speed, how much power you can supply, and all that sort of thing. But you can certainly create chains of these hundreds long. Maybe if you really want to push it, thousands. And all they do is they connect to a single pin on your microcontroller, and that can spit out the comms protocol to change them into any color. This particular image comes from Adafruit, which is it's kind of like a hobbyist electronics company. They do really great stuff, and they provide support and all that sort of stuff. You can also get them direct from China. These ones, you can see, are £1.40 for a string of 30 of them. So they're incredibly cheap, even if you want to do fairly big installations. This is a cheesy marketing video, but it does quite a good job of showing off the different forms that they come in. So I'm just going to start it and see if it breaks anything.
Hey everybody, it's me, Lady Ada, again here to show off a fun new glowy product. Today I'm going to be talking about NeoPixels. Adafruit NeoPixels are available in a wide variety of shapes and sizes, such as flexible strips, circles, squares, shields, and even sewable pixels. Adafruit NeoPixel strips are both weatherproof and super flexible, available in 30, 60, and 144 LEDs per meter. Perfect for making these sweet, glowy kicks. We also have rings in 12, 16, and 24. Sewable NeoPixels can be sewn onto any fabric with stainless steel thread and control the floor. You can make your own custom NeoPixel display with our 8x8 matrix, 8 LED stick, or Arduino shield. Also available in individual breadboard-friendly pixels. This sound-reactive tie has 16 sewable NeoPixels in it. These NeoPixel earrings are made with the 16 LED rings. The best thing about NeoPixel is how easy it is to use. No PWM drivers, you don't do...
I'll stop it there because it just sort of goes on to marketing stuff. But all that stuff is available from, from Adafruit or from loads of other manufacturers. And as you can see, it comes in loads of different forms, more than shown there, but I couldn't go through everything. So what I'm just show you now is a little bit about how easy it is to get started with these. Because if you're a software person, I'm imagining most people here are software guys rather than hardware guys and girls. So I just want to show you that you really don't need to worry about the hardware. You can just access these from software. So can I grab a couple of people to hold up? So these are literally the spare ones left over from the clock. They come in strings of 50, and I needed 104, so I've got 46 spare pixels here. So, and this is always asking for trouble to try and actually do something live. But so just scrolling to the top of the code. This is Python. You can program these in just hundreds of languages. I don't want to say you can definitely program these in every language, but I've never come across a language that doesn't have some hardware interface that can control NeoPixels, and they're mostly built in a very similar way. So in this case, just import the NeoPixel library, and you create an object which just references the pin that they're wired into. That's fine. The number of pixels, and a couple of other bits, and we define some colors here. So just going to uncomment the bit that blanks it out, and comment in the bit that blanks it out, and uncomment the bit that turns it on. This is CircuitPython specifically, and whenever you hit save, it sends the data to the code and code to the device and runs it. So you can turn your pixels red, which is kind of useful, but you could have just bought a string of red fairy lights. So the hello world of hardware is always turning an LED on and off. We're going to go slightly better and hopefully flick it between red and green. So as you can see, all this is inside a big while loop that just keeps on running, fills it with red, shows it, sleeps. Yeah, it's as simple a code as you're ever going to get. But all we've done in the previous examples, these two, we've just treated them as a whole object. So we're treating them all red or all green, which it has some uses, but it's much more interesting if you can control individual pixels. So we'll do that next. So this time the code is a little bit clunkier. But yeah, so you can see all it's doing is looping through this, and Python doesn't have a switch statement. I've no idea why, so you have to have a string of if then elifs. And it just, does a modular arithmetic and moves. It doesn't actually come out very well on this strip because the pixels are a bit further apart, but it's a rainbow moving along if you look carefully anyway. So that's how you access them. But at the moment, all we've really done is recreated some Christmas lights you could have bought from Poundland. The really interesting bit for me is that you can control them with sensors, with data from the internet, like I did with the clock. You can do something a bit more with them than you can with just passive lights that just run a pre-created sequence. So that's what we'll do in the next example, which is a little bit more complex, but hopefully we'll start working now. Yeah, so you might not be able to tell this very well, but actually it's a sound level meter. So if we can everyone just applaud for a minute? And can we just cut that in at the end? So yeah, you can just have a look at the code really simply. It grabs data from the microphone that's on the board there. It does some logging and calculates I'm not going to go through the code in detail now. But yeah, it calculates the RMS volume and then just converts that into how many LEDs you want to turn on. And that's all there is to it. That code actually is completely ripped off the examples on the Adafruit website, so you can go and have a look for yourselves if you want to know how it works. But I just wanted to show you those examples to see how easy these devices are to work with. Even if you're a software person, you can have at least plug straight into the device. I'll unplug it now anyway, I was finished. There's no components or soldering or stuff, just screw connectors. It all goes together, and you can program your lights. Thanks. with just a few lines of, in this case, Python, but you can do it from JavaScript, you can do it from C, you can do it from, yeah, name a language, you can probably do it from that. So there are a couple of things you need to be careful of. And pretty much with all hardware, it's the same two things. You need to be careful of the voltage and the current. There's the one annoying thing about NeoPixels is that they really originated in the time where most microcontrollers ran at 5 volts. So they need a signal data between 3.5 and 5 volts. These days, most microcontrollers run at 3.3 volts. And it's like so close. And it's so close that it kind of most of the time works. And you can just ignore it. And a lot of people, if you look at instructions on the internet, people will say, yeah, just connect it to a 3.3 microcontroller and it'll be fine. And about 90% of the time it will be, and about 10% of the time you'll just get weird flashing lights. So don't believe people on the internet, they're lying to you. Always make sure you're using a 5 volt or above 3.5 volt output if you're using them. And the best way of doing that, if you're sort of not that confident with hardware, is just get something that's designed to connect to NeoPixels. There's loads of it out there, and we'll go on to that in a few slides' time. The second thing you need to be aware of is the current. And I don't know if you know really what current is. It's measured in amps, and it's essentially the amount of electrons flowing through a wire. And the real problem is when you get too many going through a wire, it gets hot, and in really extreme cases, you're going to get a fire. But yeah, so with NeoPixels, each LED consumes about 20 milliamps, and 20 milliamps is very little. The trouble is the amount of them you can get. So you've got 3 LEDs in each NeoPixel. If everything's on at full brightness, by the time you hit 10 NeoPixels, you've gone above the threshold for USB, at least for regular USB, which is half an amp. As you get bigger, you can get into, it's very easy to get into tens of amps, which is around the point where you're starting to worry about setting fire to stuff. The solution to this is just to turn the brightness down. So if you look in, I don't know, scroll back. Yeah, in this, we just set the brightness there. And that just limits the maximum brightness it can go. It's between 0 and 1. So in this case, I turned them quite bright because I've got a beefy power supply. But you can turn that down to about 0.1, and then you can run 100 NeoPixels without any issues. Really, if you want to create really big, really bright displays, then you need to understand power distribution. But there's no real reason to get upset about that or worried about that. If you just want to do little ones for working inside, just be aware that it's potentially a problem. So I've done this on a Circuit Playground Express. It's a board I really like. It's got a load of sensors on there. It's connected to a Cricket. It's a bit overkill for this thing. So these are the 3 things I would really recommend for getting started with NeoPixels, but there are literally hundreds of controllers you could use. These are just my favorite. Pixel Blaze, I've put this at the top because it's programmed in JavaScript, which I thought you guys might appreciate. It's Wi-Fi controlled, so you just plug it into a power source, and it will create a Wi-Fi network. You can connect to that, and it will create its own IDE that you can sort of do your JavaScripting in, and it will run your strip. Fade Candy is slightly different from most NeoPixel controllers in that it's basically a USB device that needs a host computer to work. You plug it in, and the program actually runs on your laptop. In the examples I showed you, the program was running on the microcontroller, and it was just using the laptop to program it. Because it's done by a computer, you've got like a lot more computing power to play with. You've got more familiar programming environments. The chances are your regular IDE can just link straight into it just by including a library. And it's great as long as you only want to run it when you can plug it into a laptop. If you want to embed it, you can stick a Raspberry Pi with it as well, but it gets a bit more complex. And the Itsy Bitsy M4 is a microcontroller. It's a 3.3 volt microcontroller, but it has 1 pin that runs at 5 volts. So it kind of solves that whole problem. And you can do it with CircuitPython, which is what we've just shown, or Arduino, which is kind of a dialect of C++, which is really common in the hobbyist embedded world. Okay. So we talked a little bit about how to control LEDs and what to use, but we haven't really talked that much about why. I just showed you my clock at the start and said, here's a clock. But I think it's actually a really important thing for sort of software people to understand is that we've got so many more options than just sending stuff to a screen. You know, we're so used to having little notifications pop up or a web page that does this, but we really don't need to sort of constrict ourselves to this little LCD about sort of between that and about that. We can program anything, really. And the ability to use different materials, I think, is really important. We're so used to just a screen. And the clock I showed at the start, I could have done that with a screen. I could have got a monitor, put a strip of wood around it, and just programmed the words to appear when I wanted them to. But that's not an object I want in my kitchen. For me, it just doesn't look nice. It's not calming. It's not natural. It's not evocative. Whereas by using things like this that we can just embed into everyday devices or different materials, we can create things that, wood is calming and natural. With metal, you get this really cool, reflective sort of cyberpunk effect that can be really striking when used well. With translucent plastic, you get these sort of clouds of colour moving around, which again creates a very different effect. And it's about picking what you want and picking the materials you want to create that, rather than just using a screen because you always use a screen. You can play with scale. I mean, you can use a single NeoPixel to display something. The smallest ones are 1 millimetre or 2 millimetres across, and you can just have that flashing different colours if you want. You can light up a building with these, and that certainly happens. You can tens of metres high, and whole cityscapes can flash on and off in really interesting ways. You can think much bigger than you can with an LCD that big. And fundamentally, as technologists, it allows us to create more imaginative and original computer interfaces. And that's something we should be trying to do. We should be pushing the boundaries, and we should be engaging people in more interesting ways. And that's really why I came here to tell you guys where to go next if you are interested in doing this. Even if you're not using Adafruit NeoPixels, they have a fantastic, they call it the Uber Guide. If you just search for NeoPixel Uber Guide, it'll come up. And that tells you everything you need to know to get started. But really, it is as simple as just there's 3 wires. You plug one into 5-volt, one into ground, and one into signal. And then you can start playing with the software. That's NeoPixels. It's